I guess it depends on where we are. We're either using, maybe since we're an agriculture company, we might be using illegal labor, so it costs less than minimum wage costs. Right? $7.50. I think that's more than minimum wage, but we'll be generous. Okay. So we're paying $22.50 for that labor. Okay. We'll do that in our assumption. And now let's just start cranking the numbers.
Does that include like the labor for laying down fertilizer and stuff?
Yeah, we're assuming that's
okay.
all.
Okay.
Well, the fertilizer, you would probably pay that to the fertilizer company.
What about the one-time fee for the tree?
Well, we're going to talk about that later, but right now we're just trying to value a tree. You come to imagine, like, if the tree ends up being more than like your present value of all your cash flows, then you're going to say, it's not worth it. But if the tree was $1, maybe it's worth it. Maybe it's not even profitable with these numbers. You don't know. Okay, so here is basically like what I did for the first 10 years. And as you can see, does everyone have the model now? Did you put it up?
Yeah, it seems that everyone can get it.
Okay, why doesn't everyone go and get the model? And while you guys do that, I'll kind of just explain what's going on. So what we do is we take revenue, which was just the 15 cents times the 600 apples, and then we go through the cost for each of the different ones. So we have like $2, $10, $20. So we have $32 cost. We'll change it to the labor one when we actually go to the Excel model. And we get the profit. Well, as you see, it's like $58 a year, but we have to discount that using the time value of money for each year. So 1 year from now, $58 at a 15% discount rate. Does anyone want to just do that in a calculator? I know you have the answer right there, but just to crunch numbers yourself. Danny, are you doing it?
Sort of. Can you repeat what you said?
Yeah. So discount $58 1 year at 15%.
$49.30.
I don't think this.
$58 times 0.15, and then subtract 58 from that.
No, that's you have to do it 58 times or over 1 plus the interest rate to the first power.
Oh, that okay.
Yeah. Well, you know what? I can write it down the board.
Okay. 50.4.
Yeah, that's right. Okay, and now I know this sounds trivial because we all can do it, but let's just take some practice. And you in the white sweatshirt, what's your name?
Raul.
Raul. Okay, why don't you do it to the second year, 15%?
I gotta say I didn't really understand it.
You didn't understand? That's good. Well, I'm glad I called on you. Okay, so do you understand the formula, or do you not? Is that what you don't understand?
No, not exactly.
Okay, so you have $58 today, and you have $58 2 years from today, and you have a 15% discount rate. So you have to figure out how much the present value of it is. Here's the present value equation. Here. So you take the dollar amount, which is $58, the future value. And we talked about that 10% discount rate issue earlier, but now we're using 15%. And then we're doing 2 years, so you raise it to the second power. Is that clear?
No, sorry.
It's okay. Do you want to help him out?
No, I'm actually confused as well because if present value, if the rule is that money now is worth less than.
No, money now is worth more.
Oh, it's worth more. Oh, so now I get it.
Okay.
Is just the denominator squared or is the numerator?
The denominator. So you may not be able to see it out. For those of you on this side of the room, that's the formula. I will go rewrite it over here.
Okay, Raul, I saw you have like an aha moment. Did you get it now?
Yeah.
Okay, you want to explain it to everyone?
Okay. We have the dollar quantity, which is 58, and we divide that by 1 plus the interest rate. And the interest rate is 0.15, 15%.
So do all of you understand where the formula comes from that's on the board behind Noah? Alright, so let's try this. So we have a project. Basically, today you invest $800, and next year you get $100, the year after that you get $200, the year after that you get $300, the year after that you get $400. Instead, you can invest your money in the bank at 8%. Is it a good project to take? So that's what your cash flows look like. You have that investment, negative 800, and then a year after that you get the $100, the year after that you get $200, $400. So can somebody tell me what the this is worth today? And I'm going to call on in the green. The negative 800. What is that worth today?
I'm not sure.
It's a question. Negative $800 today is. You can plug it into the formula. It should give you the obvious answer.
It's like
So okay, so say if I were to give you $800 today, what would you value that as? $800. So yeah, that one is actually just $800. Yeah, negative $800. But now say I could give you $100 a year from now. How much would you value that today if you could put your money in the bank at 8%? So that's the same thing as saying, if you were to put your money in the bank at 8%, how much money would you have now? In a year from now. Let's see, in the blue right here.
How much money would you have?
So you have 8% interest rate at the bank. You put $100 in the bank, how much would you have a year from now? $108, right? So the question is then, if you were to discount this, how much money would you have? So when the alternative is to put your money in the bank at 8%, how much is $100? Using that formula. And that's where that formula comes from, because it's just one divided by the other.
It's like 92.59.
Right, so basically the formula would look like that. And 92.59 is right. So now, $200 2 years from now. By that same logic, let's see, over here in the blue.
wait, what? Say your name again.
I'm Eric.
Cool.
Yeah.
And
How about just briefly describe the formula?
you do the future amount, which is 200, and you divide that by 1 plus 0.08 to the second, and that would be 171.46.
Right. And that comes from the reasoning that if you put your money in the bank at 8% for 2 years, you would have that denominator in 2 years. So the value today is just what that divided by what you would get by putting your money in the bank, which is 171. So same logic, back there in the gray, 300. What does the formula look like?
You go 300 divided by 1 plus 0.08 2/3.
Right. Anybody got the number yet?
238.14.
And then over here for 400. What's the formula?
It would be 400 over 1 plus 0.08 to the 4.
Right. And so can somebody tell me if that is a good investment?
It's terrible.
Really? Have you done the math? I mean, yeah. So basically what we're saying is today, that money is worth this much, that money is worth this much, that money is worth this much, that money is worth this much. So now these are all in today's terms.
You'll lose like
It's a little
$5.
less.
I think you lose like $4.
Yeah, and that's about what it should come out to. This is 796, so